Okay, so topic for this video is going to be some word problems, some angles of elevation and depression. Our essential question, thing we're going to try to answer by the end of this video, is how is trigonometry used to solve real-world scenarios? How is it used to solve some word problems? A little recap to get us started here. Trigonometry can oftentimes be used to solve real-world scenarios by using angles of elevation and angles of depression. Let's start with an angle of elevation. So what is this thing? The angle of elevation is formed by an observer's line of sight and a horizontal line while looking up to an object. So let's draw a little picture here. My art is not the best. So here's stick figure man looking up to a tree. So our angle of elevation is going to be the line of sight, which I will do in green here. So if he's looking up to this tree, there's our line of sight, and a horizontal line. And the angle of elevation would be that angle formed right there. Okay, so we've got our line of sight going up. We've got our horizontal line coming from the eye, from eye level. And then obviously it's going to form this triangle right there, right? And that triangle there is going to be what allows us to do some trigonometry. So let's try drawing a little diagram here and seeing what we can do with number one. Once again, I apologize for my art skills. I will do my best. It says Matthew's looking up to the window of his room. If the angle of elevation from where he's standing to the window is 62 degrees and his window is 20 feet off the ground, how far is he from the base of the house? Round to the nearest tenth. Okay, so let's get this thing started here, shall we? So here is house. And here is window. And he is looking up to the window. So we'll have the ground. We'll have Matthew over here. And it says that the angle of elevation from where he is standing. So looking up is 62 degrees. So here's our triangle. And the angle of elevation from looking up is 62 degrees. His window is 20 feet off the ground. And how far is he from the base of the house? So how far is he from the base of the house? This would be our x, right? Okay, so we've made our triangle. Now we just need to do some trigonometry. So if that's the 62 degrees, then this is the opposite. This is the hypotenuse. This is the adjacent. So it looks like we want the adjacent side and we have the opposite. That is tangent. Tangent is the function that we use that uses O and A. We don't really care about the hypotenuse right here. So let's write our equation. Tangent parentheses equals ratio. Inside the parentheses always goes the angle, so that's 62. And in this case, we want O over A, so that's 20 over X. I'm going to put this over 1 so I can cross multiply. I get 20 times 1 is 20 is equal to X times tangent of 62. To get rid of the tangent 62, I should divide both sides by it. So what I'll be able to say here is that X is equal to 20 divided by tangent of 62. And that's what I'm going to type into my calculator here. I'm going to do 20 divided by tangent of 62. And I'm going to get that x is 10.6 if we round to the nearest tenth. So we will say 10.6. In this case, we're measuring in feet, so 10.6 feet. So a little over 10 feet away from the house. So obviously my diagram was not remotely accurate because it looks like that would be longer than 20, but that's what I get for my awful art. Let's go to example 2 here. 60-foot telephone pole is casting an 80-foot long shadow. What is the angle of elevation of the sun? Okay, so let's see here. We've got our telephone pole. There's the ground. This is 60 feet. And it's got an 80-foot long shadow. So we'll say this is the shadow here. Let me redraw this a little bit here. So the shadow's going this way. Now, if the shadow's going that way, then obviously the sun would have to be over here. And so the angle of elevation of the sun, in order to see the sun, we would need to be going like this, right? So that's the angle that we need to find here. The shadow's obviously on the ground. Shadows are on ground. So we want to find this angle right there. So our triangle is definitely formed right here, right? We start at the angle. We draw the arrow. That's the O. This is the H. This is the A. So it looks to me like we got to do some tangent again. Because we're using O and A. Tangent is the one that does O and A. So tangent parentheses equals ratio. Inside the parentheses always goes angle, right? So in this case, that's the x. And tangent is O over A, so this is 60 over 80. Now, for this one, since we want the angle, we don't actually want tangent. We want inverse tangent, right? Inverse tangent, we put in the ratio and we get out the angle. So now I just got to type that in. I'm just going to type in inverse tangent of 60 over 80. And I'm going to get 36.9 for my x. So what is the angle? The angle is 36.9 degrees. That is the angle of elevation. Okay, so we had one where we had to do regular trig, solving for sides. We had one where we got to do inverse trig. Let's keep going. We just need more practice drawing some pictures, I think. Angle of depression time. Okay. So what's the angle of depression? The angle of depression is formed by an observer's line of sight and a horizontal line while looking down to an object. It forms alternate interior angles with the angle of elevation. Okay, so what should we draw for a little example here? Let's just say that we've got a big cliff here that our guy's standing on. And he's looking down at something down here. Maybe it's a rock or something. The angle of depression is formed by the line of sight. So our line of sight would be going straight from where he's looking down to the object and a horizontal line. So we still need that horizontal line coming out. So the line of sight would be this one. All right, that's if we're traveling directly there. The horizontal line is the other line that we use to make that angle. So the angle of depression is formed right here. Now, interestingly, the angle of depression from the top should be the same as the angle of elevation from the bottom. like if I use this horizontal line, this would be the angle of elevation from the other side. And notice that that forms some alternate interior angles right there using our two horizontal lines as our parallel lines. Remember, alternate interior angles are always congruent if we use those parallel lines. So this would be the angle of depression. This is the angle of elevation. Okay, and those should always be the same. And you're going to see me kind of switch around on certain scenarios if it's going to be beneficial. Okay, so let's try this out. Oh, pilot, spotting the landing strip in the distance. Okay, I will attempt to draw a plane, and it will not look good, but we will try. Okay, so airplane time. Let's see what I can do here. We'll have this airplane, something like that maybe. Don't they have little fins back here too? And then they got their big wings. Something like that. There is my airplane. Maybe I should give it those little things. And it spots the landing strip in the distance. So here's the runway over here. And that's just the ground. At an angle of depression of 20 degrees. So from the cockpit here, he is looking down at the runway. Now, remember, that's the line of sight. And we still need this horizontal line to form that angle. So here's our angle of depression of 20 degrees. If the plane has an altitude of 3,400 feet, how far will the plane travel as it descends to the landing strip? Okay, so the altitude of the plane is 3,400. So that means directly off the ground, remember the altitude should go straight down and form a right angle. That is 3,400. How far will the plane travel as it descends to the landing strip? So the path that the plane's going to have to take should be that line of sight, right? It's not going to go straight down and over or anything. So what we want to find is this, because that's the direction the plane's going to have to take. So how do we do that? Here's what I'm going to do. I'm going to use this triangle right here, because that's the triangle that has the 3,400. So what I'll do is I will know that this angle down here also has to be 20 degrees, right? That's the alternate interior angle. And that's what we said. The angle of elevation from the bottom is always the same as the angle of depression from the top. So I'm going to use that triangle. So that's my O, the X is my H, and this is my adjacent. So if I know the opposite side, that altitude, and I want the hypotenuse, that's sine. Sine is O over H. So I'll do sine parentheses equals ratio. The angle is 20. This is 3,400 over X. I'm going to cross multiply. No, that's not right. This should be 3,400 is equal to X times sine of 20. Divide by sine of 20. Get that X is equal to 3,400 over sine of 20. And that's what I need to type in. So 3,400 divided by sine of 20 is giving me 99.40 0.9, and it says round to the nearest foot. So I'm going to do 9,941 is x. So that would be 9,941 feet. That is how far that this plane has to go to descend down to the landing path if he's going to keep that 20-degree angle of depression. Okay. Next up, we get a parking garage, has ramps that are 50 feet long and descend at an angle of depression of 18 degrees. What's the horizontal distance covered by the ramp? Okay, so that essentially means, like, let's draw a little ramp here. So that means this this car up at the top, if we make this angle of depression. So if you were standing at the top and you were looking down, you'd be looking down there. This would be your horizontal line. So the angle of depression is 18 degrees. So that goes right here. What's the horizontal distance covered by the ramp? Our horizontal line is this one, right? So let me flip that angle of depression down here. So I'm going to write the 18 down here. And they also said that the ramps are 50 feet long. So this is actually the ramp. That's the 50. So if I draw my arrows, that's my O, that's my H, that's my A. So this is A and H. So this is cosine. Cosine is A over H. So this is cosine of 18 is equal to x over 50. When I cross multiply, x times 1 is x. 50 times cosine of 18. That's what I need to type in here. So 50 times cosine of 18 is 47.6, because it says round to the nearest tenth. So this is 47.6 feet. And there we go. Okay, so we've done a few here. These next ones are going to be a little bit trickier because we got to take into consideration a few extra things. So let's see what's going on here. It says Gabriel is taking a picture of a rare bird in a tree he spots while on a hike. He estimates the angle of elevation of the bird to be 65 degrees. If his eye level is 6 feet and he is 20 feet from the tree, how high is the bird? Okay, so let's see here. We got Gabriel, and he is looking up to a bird in a tree. Now, I'm just going to draw the tree. Here's the tree. So this is kind of the situation that we got going on here. It's kind of like the very first drawing that we did. And these ones are a little bit trickier because they got some more numbers flying around in here that we got to be careful of. Now, the angle of elevation is 65 degrees. So the angle of elevation, of course, is formed by the line of sight and the horizontal line. So our angle of elevation is going to go right there, and that's 65 degrees. We know that Gabriel's eye level is 6 feet above the ground, and this is what makes this a little bit trickier. And he is 20 feet from the tree. And we want to know how high is the bird. Now the bird is up at where he's looking, right? So what we really want to know is this. How high up in the air is the bird? It's that question mark there. The problem is that we can't find that directly because the triangle that we're going to be working with is, how can I illustrate that? The triangle we're working with here is this blue triangle right in here. And we don't, like the question mark, the thing that we're trying to find is not a part of that triangle. So instead, what we're going to do is I'm going to put the x over here. And then we just need to remember that what we really need to do is find x and then add 6 to it. Because this entire triangle is floating 6 feet in the air because it's all taking place above this guy's head, above Gabriel's head. Now, thankfully, we do know that the base of the triangle is 20. So with that in mind, the x is the opposite side. This is the hypotenuse. This is the adjacent. So we will be doing tangent because tangent is O and A, and that's what we have. Tangent parentheses equals ratio. Put the 65 inside the parentheses. X over 20, O over A. So put this over 1 so we can cross multiply. X times 1 is x. And then we get 20 times tangent of 65. So let me type that in here. 20 times tangent of 65. I'm going to get 42.9. 42.9 for x. Okay, so what do we do with that? That's 42.9 feet. That's x, but remember, that does not take into consideration the 6 feet above the ground that this whole thing is taking place at. So really we want 48.9 feet. And that will include the 6 feet of Gabriel's height. So we got to add that back in at the end. All right, and last one here. Haley is sitting on a 25-foot pier overlooking the ocean. Her eye level is 3 feet above the pier. She suddenly sees a whale in the ocean. The angle of depression to the whale is 23 degrees. How far is the whale from the base of the pier? Okay, so we've got a pier. Here's my pier. And the pier is kind of above the water level. And Haley is sitting here, relaxing on the pier. The pier is 25-foot pier, and her eye level is 3 feet above the pier. Okay, so she's sitting, eye level's 3 feet, and then we know that the pier itself is 25 feet. And she is looking out, and then suddenly she spots a whale. And that's my whale. And we'll have the little, no, I'm not even going to do the little blow spot. That's a disaster. The whale's good enough. So what do we have here? Line of sight. We've got horizontal line. We've got angle of depression right there being 23 degrees. Now I'm going to flip that and I'm going to use this triangle. Because all in all, that 3 feet above the pier and the 25-foot pier, all in all, that gives me 28 for the opposite side. Remember that 23-degree angle is going to get flipped down here into the angle of elevation. And we want to know how far is the whale from the base of the pier. That's right here. So now that we kind of understand what's going on, the 28 is the opposite side. This is the adjacent side. That's the hypotenuse. I'm doing tangent. T is O over A. tangent of 23 is equal to 28 over x, the 25 feet for the pier, the 3 feet for the eye level above the pier. We cross multiply. 28 times 1 is 28. X times tangent of 23. Let's divide. Divide both sides by tangent of 23. And what are we going to get here? 28 divided by tangent of 23 is 65.96. That just rounds to 66. So we'll say that that whale is 66 feet away. Man, that was quite the drawing there. Hopefully you understand what I was trying to illustrate there. Okay, it is now your turn to try a few. You've got 2 to try out. You've got Ella flying a kite, and you've got a man in a lighthouse. Try to draw some pictures, give those a shot, and then come back when you're ready to see how you did. All right, so hopefully that went well. We've got Ella here flying a kite. There's my kite with a 50-foot string. Angle of elevation is 65 degrees. So up and out is 65. And we want to know how high this kite is. So that should be our X. So that's my O, that's my H, this is my A. I'm doing sine. Sine is O and H, and that string is the hypotenuse. We want to know how tall it is with the X. So let's do sine of 65 is equal to X over 50. Cross multiply, get X is equal to 50 times sine of 65. And what do we get? 50 times sine of 65 gives me 45.3. 45.3 feet high. All right, and then lastly, we got a man at the top of a 100-foot lighthouse. So here's our guy. He's up at the top of this lighthouse, and he spots a ship approaching in the fog. There's our ship. Lighthouse is 100 feet, and he spots him. So he's looking at him with that line of sight. Measures the angle of depression to be 32 degrees. So here's our 32. There are rocks that could be dangerous to the ship 120 feet out from the lighthouse. Okay. So here's some jagged rocks. And we know that the rocks are 120 feet from the lighthouse. So, oops. Actually, draw it like this. So from there to there is 120. How far is the ship from the rocks? Now that's interesting. Now what I'm going to do actually first here, I'm going to ignore the rocks. I'm just going to figure out how far is the boat from the lighthouse. So I'm going to call this whole thing here X. I'm going to use the alternate interior angles to place a 32 down here. That's my O. That's my H. This is my A. So let me do some tangent. So tangent parentheses equals ratio. Tangent of 32 is equal to 100 over x. Cross multiply, get 100 is equal to x times tangent of 32. Let me divide. Let's see what we get when we do that. 100 divided by tangent of 32 gives me x to be 160. And I guess that's just 160 feet. So if the boat is 160 feet away and the rocks are 120 feet from the lighthouse, 160 minus 120 tells me that boat is only 40 feet away from those rocks. It is getting close. They better radio in and warn that boat. That is for sure. All right. Hopefully that went well for you. That was a fun little last problem there. I hope you guys figured that one out. And that's going to wrap this video up.